So as with the log worksheet last time, I'm not going to go through and calculate them all, so you can check work, pause the video if you need to. You're just using the common log button on your calculator for part A and the natural log button on your calculator for part B. You also had to do number 18 on the reference angle worksheet. Number 18, we are slowly making our way through that. They told us that sine theta is equal to 5 over 13 and tangent theta is less than 0. Alright, so just so we get an idea of what quadrant I'm working in, remember forecast. If sine is positive 5/13, that means I can be in quadrant 1 or I can be in quadrant 2. But if tangent is less than 0, that means tangent's negative, and that happens in quadrant 2 or quadrant 4. So I have to be in quadrant 2. So we go ahead, find our inverse tangent of both sides. So theta is equal to the inverse sine. Sorry, I think I said tangent. Theta is equal to the inverse sine of 5 over 13, which gives you 23 degrees. Alright, but 23 is in quadrant 1, and I want to be in quadrant 4, so 23 is going to serve as my reference angle. So to find my actual theta, I'm going to do 180 minus 23 because I'm in quadrant 2, and that will give me 157 degrees. Hopefully we're starting to get pretty good at these. Moving on the factoring worksheet that I gave you guys last class, remember separate paper, we had to do 1, A, B, and C. So here's 1A. We had to factor by grouping. So we have x cubed minus 7x squared minus 8x plus 56. Remember to do factor by grouping, we just draw a nice line down the middle. And then I look for the GCF of each of my two groups. On the left side, I've got a GCF of x squared, and I'm left with an x minus 7. On the right side, remember we always want to pull out a negative if I've got a negative out in front. So on my right side, I'm going to plot a negative 8, and I'm going to be left with x minus 7. So now looking at my two groups, I have a GCF from each group of x minus 7, and I'm going to be left with x squared minus 8. And this is your final answer. All right, x squared minus 8 does not factor. It's not the difference of perfect squares. For 1b, I had 2x cubed plus 5x squared plus 22x plus 55. Go ahead, draw my line down the middle. So here I'm going to have a greatest common factor of x squared on the left, and I'm going to be left with 2x plus 5. And on the right, I have a GCF of 11, and I'm going to also be left with 2x plus 5. So looking at both of my groups, I have a GCF of 2x plus 5, and I'm left with x squared plus 11, and that is your final answer because neither of those can factor anymore. Moving on to 1c, they give me 2y squared plus 4y plus 6x plus 3xy. Again, draw my line down the middle. My left side GCF is going to be 2y, and I'm left with a, when I pull a 2y out, I'm left with y plus 2. And on the right side, I have a GCF of 3x, and I'm going to be left with 2 plus y. Okay, and these are the same thing. Remember, addition is commutative. So I've got a GCF of y plus 2, or 2 plus y, it doesn't matter. And then I'm left with 2y plus 3x. And that is your final answer because neither of those factor anymore. Moving on to question 2, 2b, or not 2b. 2b gives us y cubed minus 5y squared minus 9y plus 45 is equal to 0. All right, for question 2, we're actually solving. So after we find our factors, we're going to set them equal to 0 and actually solve for our variables. But I got a factor first, so I'll draw my line down the middle. Here I've got a GCF of y squared, and I'm left with y minus 5. Here I pull out the negative, so I'm pulling out a negative 9, and I'm left with y minus 5. So that means that my factors are y minus 5 and y squared minus 9. All right, and I'm not done because y squared minus 9 is the difference of perfect squares. So this keeps factoring into y minus 5 times y minus 3 times y plus 3 is equal to 0. And if all these things multiply to 0, that means that y minus 5 equals 0, or y minus 3 equals 0, or y plus 3 equals 0. So I get y equals 5, or y equals 3, or y equals negative 3. And you're done. Alright, so for number 2, you had to go past the factoring. You actually had to solve for your variable. For 2e, they gave us 3m cubed. 3m cubed plus 6m squared minus 48m minus 96 is equal to 0. So let's see. First, on my left side, I have a GCF of 3m squared, and I'm left with an m plus 2. And on the right side, I just tested it in my calculator, there's actually a GCF of negative 48. And I'm left with m plus 2. So I got m plus 2, and I'm left with a 3m squared minus 48. And I'm pretty sure there's a GCF of 3 on that right side. There is. So here I've got my m plus 2. I can factor a 3 out, and I'm left with m squared minus 16. Okay, and usually we don't write the constant in the middle, so I'll move this 3 over to the left so it looks a little more normal. And I'm still not done factoring because now I have the difference of perfect squares. So this factors into m minus 4 and m plus 4. So that means that m has to equal negative 2, or m has to equal 4, or m has to equal negative 4. Alright, something that I want to point out is that notice our highest exponent was a 3, and I got 1, 2, 3 answers. Alright, that is not a coincidence. And you also had to do 2g, and they give us xy plus 7x plus 6y plus 42 is equal to 0. Draw my line. On the left, I have a GCF of x, and I'm left with y plus 7. And on the right, I have a GCF of 6, and I am also left with a y plus 7. So my factors are y plus 7 and x plus 6. So that means y is equal to negative 7, or x is equal to negative 6. Okay, and you did have to do questions 3, 4, and 5 from the book. It was proving trig identities. I put a screenshot of it on my big canvas, but we're going to go over those in class. All right, so make sure you do them, but those we're going to go over in class, and peace out.